Hello and welcome back to another IB Math Speedrun with me, Vince. So today we're going to be going through chapter 7.4 of the IB Math textbook, which is all about integration techniques. There's a lot to cover, so let's jump right in. So there are a lot of tricks we need to use for integration, but the first one we need to know is integration by inspection, which is more or less just looking at a function and being able to integrate it. So these are some rules that you might want to memorize. So first of all, of course, fundamental theorem of calculus, f of x dx is equal to an antiderivative plus a constant. That's basic. Next, these are all derived from getting the derivatives. So e to the x dx is of course equal to e to the x plus c. We have 1 over x dx is equal to ln x plus c. We have e to the ax plus b dx is equal to 1 over a e to the ax plus b plus c. And then we have 1 over ax plus b dx is equal to ln ax plus b, 1 over a actually, ln ax plus b plus c. And then we have, of course, a to the x dx is equal to a to the x over ln a plus c. And finally, this is a quite important one. If we have the integral of a derivative of a function over the function itself, then this is equal to the natural logarithm of the function plus c. So yeah, those are quite important. And the other thing we want to solidify is the reverse chain rule. So we touched on it briefly, but now let's actually define it. So the reverse chain rule is this rule that states that the derivative of if we get the derivative of a compound function, so f of g of x, which is of course equal to the derivative of f of x times g of x times the derivative of g of x. So therefore, the integral, I cannot draw, the integral of the derivative of f of x of g of x times g prime is equal to the original compound function. It's equal to f of g of x. So yeah, this is quite important, and so now to practice this, let's jump into some questions. So the first question, I'll do the even ones, I guess. So first we need to find the following integrals. The first one is the integral of 3e to the x plus 1 over 2x plus sine x dx. And so this is pretty simple. We can split this apart into different ones. First, will be 1/3. This will still be 3e to the x. This over here will be 1/2 ln 2x. Since we need to get the derivative of this, and we would normally expect it here. And now we need to, this would be negative cosine x plus c. So that is the derivative, integral, sorry. Next, we have tan squared 3x plus 1 dx. So we need to get the integral of this. Tan squared is, sorry about that. Anyways, how we solve this one is actually we use the trigonometric identity that secant squared x is equal to tangent squared x plus 1. This is because if we divide everything by cosine 2x, yeah. So therefore this integral is actually equal to secant squared 3x to dx, which is of course equal to 1/3 tangent of 3x plus c. So yeah, that one was cool. And then on to the next one. And the next one is the integral of 3 over 1 minus 3x dx. So this is simply negative ln 1 minus 3x plus c. Since if we get the derivative of the inside, it's equal to negative 3, and since it's positive over here, we just need to make the overall natural logarithm negative. Okay, next we have cosine x e to the sine x minus 2 over x dx. So we should recognize that cosine x is actually the derivative of sine x. So this integral is actually equal to e to the sine x by chain rule minus 2 ln x, since this should be 1 over x for just ln x itself. So this is part of inspection, and yeah. So next, find f of x given the extra conditions. So we have f prime of x is equal to 2x minus sine 4x, and f of 0 is equal to 0. So if we integrate 2x minus sine 4x, this should be equal to x squared plus 1/4 cosine 4x. And we know that f of 0 equals 0. So 0 is equal to 0 plus 1/4 minus, so the c should be minus 1/4. So we have x squared plus 1/4 cosine 4x minus 1/4. Next, we have f of x is equal to 3 over 2x minus 5. Minus 3x squared minus 3e to the x minus 1. X minus 3, sorry. And then f of 3 is equal to 25, negative 25. So we can solve this. So if we take the integral of that entire thing, which I'm just not going to draw it, f of x should be equal to 3/2 ln 2x minus 5 minus x cubed minus 3e to the x minus 3 plus c. And so since we have f of 3 is equal to negative 25, we have negative 25 is equal to 3/2 ln 1 minus 27 minus 3e to the 0, so minus 3 plus c. ln 1, of course, being 0, so this entire thing is 0. So you have negative 30 plus c, so c should be equal to 5. So we have 3/2 ln 2x plus 5 minus x cubed minus 3e to the x minus 3 plus 5. Yep, that's correct. Okay, next we need to evaluate the following definite integrals and check your answers. I'm not going to check the answers, let's just evaluate them. We have the integral of between pi and 3 of 0 of e to the 3x minus 2 plus sine x dx all. So this is equal to pi over 3 0 of 1/3 e to the 3x minus 2 minus cosine x. So this is equal to 1/3 e to the pi minus 2 minus cosine pi over 3. Cosine pi over 3 is equal to 1/2 minus 1/3 e to the negative 2 plus cosine 0, 1. So it should be equal to 1/4 e 1/4 e to the 2x minus 1 minus 1/2 sine 1 minus 2x. Oh, that's the wrong one. I'm looking at the wrong one, sorry. 1/3 e to the minus 2 e to the pi minus 1 plus 1/2. Yeah, so in other words, we just rearranged it and we should get the correct answer. So next we have the integral between 1 and 0 of 3 to the x minus 6 over 1 minus 3 to the x dx. So this is equal to 3 to the x. The integral of this should be 1 over ln3, I believe, times 3 to the x. Is this correct? Yeah. Minus, so this would be plus 2 ln 1 minus 3x. So this is equal to 1 over 3 to the 1, so what? 3 over ln 3 plus 2 ln negative 2 minus 1 over ln 3 plus 2 ln 1, which is 0. So yeah, so we should get something like 2 over ln 3 plus 2 ln of negative 2. Wait, negative 2? It might be positive 2. Yeah, it should be positive 2 since ln technically has the absolute value function after it. So 2 ln 2 is of course ln 4. So we have 2 over ln 3 plus ln 4. Next, we have between 4 and 2 of 2x over x minus 1 dx. Okay, so the real way to do this would be, actually not the real way, but the way we're going to do this is we're going to split this into partial fractions. So we get, this should be equal to 2 plus, I think it's 2 over x minus 1. Since 2x is equal to 2 times x minus 1 plus 2. So yeah, now we can integrate this. Okay, so just partial fractions trick. So we get bounds for 2 of 2 plus 2 ln x minus 1. So we get 2 plus 2 ln 3. 2x. So this is actually 2 times 4, 8, plus 2 ln 3 minus 4 plus 2 ln 1, 0. So this would simply be 4 plus 2 ln 3. Yeah. Okay, on to the next one. Next one is the integral between pi over 4 and 0 of sine 2x over cosine x dx, which is actually quite interesting because of course we can expand this into 2 sine x. Actually, this is just equal to 2 sine x dx, since this is sine x, 2 sine x cosine x. So if we integrate this, this will be equal to pi over 4 and 0 of negative 2 cosine x, which is equal to negative 2 times, so negative root 2 plus 2. So it's, yeah, just negative root 2 plus 2, or 2 minus root 2. Okay, and then on to the final one, which is the integral between 1/2 and 0 of 2 to the x plus 2 over 1 minus x. dx. And so I think we can just integrate this one on the spot. This is equal to 1 over ln 2 times 2 to the x plus, minus 2 ln 1 minus x. So this is equal to 1 over ln 2 times 2 to the 1/2, so root 2 over ln 2 minus 2 ln 1/2 minus 1 over ln 2 plus 2 ln 1, which is 0. So we get root 2 minus 1 over ln 2 minus 2 ln 1/2 is what I got. Yeah. And of course, this is equal to ln 4 if you want to convert it that way. So yeah, next question is reduce y is equal to x plus 9 over 2x squared plus x minus 3 into partial fractions and, well, more or less find the integral of it. The indefinite integral. And so we can reduce this into partial fractions because we know that this should be equal to 2x squared plus x minus 3 is equal to 2x plus 3 x minus 1. So we know that x plus 9 is equal to a times x minus 1 plus b times 2x plus 3. We covered this a long time ago. So we have 1 is equal to a plus 2b, and 9 is equal to negative a plus 3b. So we have a is 3b minus 9, so we have 1 is equal to 3b minus 9 plus 2b, so b is equal to 2, and a is equal to 6, negative 3. Yeah. So we have this is equal to the integral of negative 3 over 2x plus 3 plus 2 over x minus 1, which is equal to negative 3 halves ln 2x plus 3 plus 2 ln x minus 1 plus c. So yeah, partial fractions, integration. Partial fractions is very important for integrating stuff. Ln, usually absolute value. Absolute value, absolute value. Okay, next question. We have express y. Just find the integral of 5x plus 9 over x squared minus 9, which of course we can rewrite as x plus 3 times x minus 3 dx. So we have 5x plus 9 is equal to a times x minus 3 plus b times x plus 3. So we have 5 is equal to a plus b, and then we have 9 is equal to negative 3a plus 3b. So we have, of course, a is equal to b plus b minus 3. So 5 is equal to 2b minus 3. So b is equal to 4, and a is equal to 1. 16 minus, 12 minus 3, 9, yeah. So this is equal to the integral of 1 over x plus 3 plus 4 over x minus 3, which is equal to ln x plus 3 plus 4 ln x minus 3. plus c. So yeah, pretty good. And then I think we are on to the final question. Yeah. And so the final question is, show that 1/2 0 of 2 plus 3x minus x squared over 1 minus x squared dx. So it's another partial fractions trick. It's equal to 1/2 plus ln 8 over 3. So partial fractions trick, let's do this one. 1 minus x squared is equal to 1 plus x times 1 minus x. But we will also have a term that is independent of all the fraction terms. So more or less we can have 2 plus 3x minus x squared is equal to a times 1 minus x times 1 plus x. This will be the integer term we take out, plus b times 1 plus x plus c times 1 minus x. So we get a triple equation. So we have negative 1 is equal to negative a. Okay, so negative 1 is negative a. 3 is equal to b minus c, and 2 is equal to negative a plus b plus c. So we already know that a is equal to 1. So we can rewrite this integral as the integral between 1/2 and 0 of 1. So now we're left with two equations. So this one is negative 1. So we have 3 is equal to b plus c, and 3 equals b minus c. So in other words, c is actually equal to 0 and b equals 3. So this is going to be 1 plus 3 over 1 minus x. Okay, pretty interesting. Dx, which is equal to 1/2 and 0 of x plus minus 3 ln 1 minus x. So if this is between 1/2 and 0, this is equal to 1/2 minus 3 ln 1/2 minus 0 minus plus 3 ln 1, 3 ln 1 being 0. So this is equal to actually 1/2 plus 3 ln 2, which is equal to 1/2 plus 3 ln 8. Oh, ln 8 thirds, hold on. Where did 8 thirds come from? Oh, sorry, no, because we flipped. Oh, yeah, no, my bad. This is 1/2 minus 3 ln 1/2, which is equal to 1/2 minus, actually it's ln 1 over 8. Why is this? Oh, it's actually 1. Oops. Yeah, my bad, sorry. So b is equal to 2, c is equal to negative 1. Oopsies. So yeah, we need to rewrite this a little. Sorry, I made a little mistake there. So we have not plus 3x minus 1. We actually have b is 2, c is negative 1. So this is 1/2. Oh, sorry, 1 plus 2 times 1 minus x minus 1 times 1 plus x dx. So this is equal to 1/2 and 0 of x plus, no, minus 2 ln 1 minus x minus ln 1 plus x. Okay, let's see what we get now. So this is 1/2 minus 2 ln 1/2 minus ln, freezing, ln 3/2 plus 0, 0, 0. Okay, so this would be equal to 1/2 minus 2. Oh, well, hold on, wait, let's think. This is ln 1/4. And so we have ln 1/4 times 3/2, ln 3/8. So this 1/2 plus ln 8/3. So yeah, we've successfully proved it equals ln 8/3. So yeah, that's all for the speedrun, and I hope to see you in the next one. So see you then.